Pakistan-made JF-17 Thunder Block II jets have been spotted in the Nigerian Air Force (NAF) paint scheme, which suggests they can head to Abuja for the November 2020 delivery schedule. Images appearing on social media show the round, blue and white NAF logo on the wing of the JF-17 Thunder aircraft. Another image shows the front of the plane from top to bottom, showing the same logo on both wings. The tail number or even the Nigerian flag is not visible. The images were posted on November 6 with the permission of a Nigerian defense fan at Defense Nigeria without citing any sources. The accompanying post said the Nigerian pilots and ground crew had completed training in Pakistan and were leaving for Nigeria soon. In March 2019, the Pakistani government's Economic Coordination Committee approved a $184.3 million sovereign guarantee covering the delivery of 3 JF-17 Block II Thunder fighter jets to the Nigerian Air Force. According to Pakistani media reports, the jets, worth $61.2 million each, include a missile complement, laser-guided bombs and targeting pods supplied by China. The price of a single JF-17 Block II aircraft was around $30 to $35 million. Chinese industry sources have informed, during the 2019 Moscow Air Show, that the Nigerian order is being jointly executed by Pakistan Aeronautical Complex (PAC) and Aviation Industry Corporation of China (AVIC). The latter is tasked with supplying weapons, targeting pods and other sensors, and their maintenance and training. The initial batch of 3 aircraft could be followed up with more orders if they blend with NAF requirements, the source said. Unconfirmed reports on social media say Nigeria is negotiating an order for another 40 aircraft. The JF-17 Thunder is a lightweight, single-engine, multi-role combat aircraft developed jointly by the Pakistan Aeronautical Complex (PAC) and the Chengdu Aircraft Corporation (CAC) of China. It was designed to replace the A-5C, F-7P PG, Mirage 3, and Mirage V combat aircraft in the Pakistan Air Force. The JF-17 can be used for multiple roles, including interception, ground attack, anti-ship, and aerial reconnaissance. Its designation JF-17 by Pakistan is short for Joint Fighter 17, while the designation and name, FC-1 Xiaolong, by China means Fighter China 1 Fierce Dragon. The JF-17 can deploy diverse ordnance, including air-to-air and air-to-surface missiles, and a 23mm GSH-23-2 twin-barrel autocannon. Powered by a Guzhou WS-13 or Klimov Road 93 afterburning turbofan, it has a top speed of Mach 1.6. The JF-17 is to become the backbone of the Pakistan Air Force (PAF), complementing the General Dynamics F-16 Fighting Falcon at half the cost. The PAF inducted its first JF-17 squadron in February 2010. In 2015, Pakistan produced 16 JF-17s. As of 2016, Pakistan is believed to have the capacity to produce 25 JF-17 per year. 58% of the airframe is Pakistani and 42% Chinese-Russian origin. As of December 2016, Pakistan Aeronautical Complex has manufactured 70 jets in the country for use by the Pakistan Air Force of the Block I type, and 33 jets of the Block II type. The Pakistan Air Force plans, by 2017, to induct a twin-seater version known as the JF-17B for both enhanced operational capability and training. Preparations for a more advanced and technologically sophisticated Block III version of the aircraft are underway, and the AESA radar, KJ-7A, has been developed, which can track 15 targets and engage 4 targets simultaneously. Since its induction in 2011, the JF-17 Thunder has accumulated 19,000 hours of operational flight. The airframe is of semi-monocoque structure constructed primarily of aluminum alloys. High-strength steel and titanium alloys are partially adopted in some critical areas. The airframe is designed for a service life of 4,000 flight hours or 25 years, the first overhaul being due at 1,200 flight hours. Block II JF-17s incorporate greater use of composite materials in the airframe to reduce weight. The retractable undercarriage has a tricycle arrangement with a single steerable nose wheel and 2 main undercarriages. The hydraulic brakes have an automatic anti-skid system. The position and shape of the inlets is designed to give the required airflow to the jet engine during maneuvers involving high angles of attack. The mid-mounted wings are of cropped delta configuration. Near the wing root are the LERX, which generate a vortex that provides extra lift to the wing at high angles of attack encountered during combat maneuvers. A conventional tri-plane empennage arrangement is incorporated, with all moving stabilators, single vertical stabilizer, rudder, and twin ventral fins. The Flight Control System (FCS) comprises conventional controls with stability augmentation in the yaw and roll axis and a digital fly-by-wire (FBW) system in the pitch axis. The leading edge slats, flaps and trailing edge flaps are automatically adjusted during maneuvering to increase turning performance. The FCS of serial production aircraft reportedly have a digital quadruplex quad-redundant FBW system in the pitch axis and a duplex dual-redundant FBW system in the roll and yaw axis. The glass cockpit is covered by a transparent, acrylic canopy that provides the pilot with a good, all-round field of view. It has 3 large multifunction color displays MFD and smart heads-up display HUD with built-in symbol generation capability. A center stick is used for pitch and roll control while rudder pedals control yaw. A throttle is located to the left of the pilot. The cockpit incorporates hands-on throttle and stick HOTAS controls. The pilot sits on a Martin Baker Mk16 La00 ejection seat. The cockpit incorporates an electronic flight instrument system EFIS and a wide-angle, holographic head-up display HUD, which has a minimum total field of view of 25 degrees. The EFIS comprises 3 color multi-function displays, providing basic flight information, tactical information, and information on the engine, fuel, electrical, hydraulics, flight control, and environment control systems. The HUD and MFD can be configured to show any available information. Each MFD is 20.3 cm, 8.0 in wide and 30.5 cm, 12.0 in tall and is arranged side by side in portrait orientation. The central MFD is placed lowest to accommodate a control panel between it and the HUD. Up to 3,629 kilograms, 8,001 pounds of ordnance, equipment, and fuel can be mounted under the hardpoints, 2 of which are on the wing tips, 4 are under the wings and 1 is under the fuselage. The avionics software incorporates the concept of open architecture. Instead of the military-optimized Ada programming language, the software is written using the popular C++ programming language, enabling the use of the numerous civilian programmers available. The aircraft also includes a health and usage monitoring system, and automatic test equipment. The JF-17 has a defensive aids system (DAS) composed of various integrated subsystems. A radar warning receiver (RWR) provides data such as direction and proximity of enemy radars, and an electronic warfare (EU) suite housed in a fairing at the tip of the tail fin interferes with enemy radars. The EU suite is also linked to a missile approach warning (MA) system to defend against radar-guided missiles. The MA system uses several optical sensors across the airframe to detect the rocket motors of missiles across a 360-degree coverage. Data from the MA system, such as direction of inbound missiles and the time to impact, is shown on cockpit displays in the HUD. A countermeasures dispensing system releases decoy flares and chaff to help evade hostile radar and missiles. The DAS systems will also be enhanced by integration of a self-protection radar jamming pod that will be carried externally on a hardpoint.